today we are discussing the most important component, that is a resonator, which work on the frequency. So we are discussing the how a resonator work. So resonators work based on the principle of the resonance, means principle of vibrations, which is a tendency of the system to oscillate at a specific frequency when it is subjected to an external force at that of same frequency. So here how the resonator typically works, it works on the natural frequency. What is this natural frequency? Every physical system has a natural frequency at which it tends to vibrate or oscillate when distributed. This natural frequency is determined by the system's physical properties such as mass, stiffness and the damping. Another parameter is the external excitation. When an external force or input signal is applied to the resonator at or near its natural frequency, the system begins to vibrate with the increasing amplitude. So, this is because the system absorbs the energy from the external force and store it temporarily. Another parameter is the energy exchange. As the system vibrates, energy is exchanged between the potential energy stored in the system elastic elements and the kinetic energy that is associated with the system motion. So, energy exchange is there. As a system vibrates, energy is exchanged between the potential energy and the kinetic energy. So, this energy exchange causes the system to resonate at its natural frequency. Another parameter is the amplification. A resonator amplify signals at their natural frequency while attenuating signals at other frequency, and this selective amplification is due to the constructive interference of the input signal with the resonator's natural response. So, another which is the most important parameter is the resonance and the response. When we talk about the resonator, what is the response of the resonator? When an external force is removed, the resonator continues to vibrate at its natural frequency due to the stored energy. So, this sustained vibration is known as the resonance when there is no external force applied to the resonator, and this sustained vibration is the resonance, and the resonator's response at this frequency is typically stronger than that of the other frequency. So, these are the working parameters of the resonator. Now, it is very important that how we choose the right resonator. So, choosing the right resonator for the applications. So, when selecting a resonator for any electronic application, several factors need to be considered to ensure optical performance and the functionality. So, these factors include the frequency range, stability, requirement, accuracy, size constraints and the cost consideration. So, these are the most parameters for the choosing the right resonator for a particular application. Again I repeat, first is the frequency range, second is the stability requirement, third is the accuracy, then the size constraints and the cost consideration. So, the frequency range is one of the most critical consideration. So, different resonator have the specific frequency range, they can operate within that frequency range because the output we are getting, the amplified output we are getting. So, a frequency range must be defined for the resonator, and it is essential to choose a resonator that can generate or amplify the frequency within the desired range for any application. Another parameter which is stability is another crucial factor to consider. If your application requires the precise and the stable frequency control, so resonator like quartz and crystal resonators would be the ideal choice. and these type provide the excellent long term stability and the frequency accuracy. Means quartz and crystal resonator we will use when we just require the longer stability and the frequency accuracy. Accuracy is closely related to the stability and is an important application that demand the precise timing and synchronization or the frequency control. Quartz and crystal again resonators are known for their high accuracy, while other type of the ceramic or SA resonators may have the slightly lower accuracy but offer the cost effective alternatives. So, size constraints should also be taken into the account, especially in the space consideration design. And whenever we just design the resonator for a military purposes or for a space purposes, so the size is also the important. So ceramic and the SA resonators are compact and the lightweight, making them suitable for devices with the limited space. Quartz crystal resonator while having the larger size and can still be incorporated into the larger system of the application with the less space limitations. Lastly, the most important parameter is the cost. Cost is a significant consideration. If we require in the bulk, so the minimum cost we require for a preparation of the resonator. So different resonator types vary in the cost, with the ceramic resonators generally being the most affordable and the quartz or the crystal resonators being the more expensive. So it is important to strike a balance between the desired performance and the budget constraints of the project, or you can say of the device. Overall, choosing the right resonator for any application requires the careful consideration of the frequency range, stability, accuracy, size and the cost. By evaluating these factors, matching them to the requirement, a specific device can be generated. What are the application of the resonator in the electronics? As we are talking about the electronic resonator, and further we will discuss about the types of the electromagnetic resonator in detail. So first we discuss what are the application of these resonator in the electronics. So resonators plays a vital role in the various electronic application, providing the stability, accuracy and the frequency control. And it is used in the oscillators. Number first application is we use it in the oscillators. Resonators are frequently used as a frequency determining element in the oscillator. Oscillator generates a continuous waveform at a specific frequency and are crucial in the functioning of the devices like clock, microcontroller and the communication system. Another application is in the filters, as the frequency can be pass or the stop through these filters. So resonators are used in the filters to selectively pass or reject the specific frequency. And filters are essential in the signal processing and the noise suppression, ensuring the accuracy and the quality of the electronic signals. Means the valuable signal should not be loss. Resonators help archive precise frequency, and we can have the various control in the filter circuit. Another we use in the communication system. So resonators are integral to communicate the signals through the wireless network. So resonators are the integral to communication system, which includes the wireless network, cellular phones and the two-way radio, and they provide the stable frequency generation and the control, and allowing for the reliable and accurate signal transmission and the reception of the signal. So another is the timing circuit. Resonators are crucial in the timing circuit, such as a clock and the timers, where precise timekeeping is required, and they provide the accurate frequency control to ensure the precise timings and the synchronization in the various electronic devices and the system. Another important application in the sensors. So, resonators are employed in the various sensor application, which includes the temperature sensors, pressure sensors and the gas sensor, and they convert the external stimuli or the physical changes into the electrical signal and allowing for the accurate and reliable sensing capabilities. Another use of the resonator in the medical devices, and there are the many applications of the resonators in the medical devices, such as we use it in the ultrasound machine and the medical imaging equipments, and they are utilizing for the generation or the manipulation of the specific frequencies, enabling the accurate and the high resolution imaging and diagnostics. And in the consumer electronics, resonators are used in the everyday consumer electronics, including the television, radios and the smartphones, to ensure the accurate frequency reproduction and reliable performance. Scientific instrument and resonators play a vital role in the scientific instruments like spectrometers, atomic force microscopy and particle accelerator. They contribute to the precise frequency control, spatial operation and accurate measurement and in these advanced scientific devices. In the industrial application, resonators find the applications in the industry such as manufacturing, the automation, robotics, and they are used in the motor control, motion sensors, precision instrument to ensure the smooth and accurate operations. So, these are just a few examples of the wide range of application where the resonators are utilized in the electronics. Resonators are essential components that contribute to the stability, accuracy and frequency control in the various devices in the system across the electronic circuits. So, what are the limitations of the resonator? Resonators have a several benefit in the field of the electronics, but they have a certain application. So, understanding of the certain limitations means the first is the cost. Certain type of the resonator such as quartz and crystal and resonators can have the more expensive as compared to the other type, and this cost factor needs to be considered in the budget constrained application. And there are the another type of the ceramic SAW resonator may be the suitable if we talk about the cost. Temperature sensitivity, some resonators including quartz crystal resonators can be sensitive to the temperature changes. So, this sensitivity can affect their frequency stability and accuracy, that requiring the additional measures like temperature compression and or the environmental control in the some application. Another is the frequency range. Resonators have a specific frequency ranges within which the operates optimally. Choosing the right resonator necessarily matches with the desired frequency requirement of the application with the resonators capabilities. Another is the size limitations, as we already discussed that the some resonators such as a quartz having a larger size, but it is a challenges to design within the limit of the space or the size constraints. So, smaller alternate in the smaller alter in the resonator, we can just prepare the small or the different type of resonator. Overall resonators offer the numerous benefit in the terms of the frequency control, stability, accuracy and the compactness. However, it is important to be aware of their limitations such as the cost, temperature sensitivity, frequency range and the physical sizes. By understanding these factors, one can design and can be select a effective utilization of the resonators in and the electronic gadgets. So, there are the some advantages of the resonator in terms of the ceramic. We have the less expensive alternative that still achieve high precision level, ceramic is often chosen for the cost effective in the priority. Similarly, MEMS, it is a compact design and ideal for the portable devices, making the perfect and the small electronics. Durability, resonator have quartz well known for their long lifespan and resistance for the environmental condition, making them reliable over the time. So, there are the timing and clocks that we have discussed in the communication system we have. Now, we discuss about the various type of electromagnetic resonator. So, resonators that performance on the range of RF and the microwave components, we are having the various type. First is the cavity resonator, second is the coaxial, third is the transmission line resonator, dielectric resonator, crystal resonator, quartz resonator, ceramic resonator, surface acoustic wave SAW, piezoelectric resonator, yttrium iron garnet, YIG, MEMS resonator. So, given this variety of the resonator, it is essential to design to understand characteristics of the various resonator. So, first is the cavity resonator. So, cavity resonators are the vacuum enclosed metallic structure where the electromagnetic waves are trapped. So, the dimension of the cavity also play an important role for defining the resonant frequency. So, these resonators are the quite proper for the microwave engineering and can be cylindrical or the rectangular in the shape. Another type of we are having the two type. First is a cylindrical waveguide resonator. They are assumed to behave like a transmission line which is connected to the short or the open circuit, that is extremities. So, thus making it resonator. When the open end vibrates, they can also act as an antenna. Another is a rectangular wave resonator. That is also the cavity resonator, and like the cylindrical waveguide, rectangular waveguide short circuited at both the ends have their resonant frequency, and this resonator are commonly employed in radar and the communication application. Another type of resonator is the coaxial resonator. Coaxial resonator are commonly used to design the component like voltage control oscillators or the coaxial resonator oscillators. So, these resonators are commonly used designed for the component like the voltage control oscillator, coaxial resonator oscillators and the filters, that is VCO, CROs and the filters. Coaxial resonator have their form of resonator that is essential a ceramic coaxial line, and often coaxial resistors are implemented in oscillators as high quality factor, that is the high Q indicators, and thereby creating a resonant circuit when paired with the capacitor and the vector diode. So, a coaxial resonator has an outer conductor with an approximately square shaped cross section and a cylindrical central conductor. So, coaxial resonator have the two different forms. First is a quartz wavelength, that is lambda by 4 resonator with one and the shorted and opposite and open, and a half wavelength, that is lambda by 2 resonator with the both the ends open, means one end shorted and opposite end are open in the quartz wavelength, but in the half wavelength both ends are open, because a coaxial resonator material has a high dielectric constant value. So, component design with them can be reduced in the size, and that can be range from the 10 to 100 hertz. So, ceramic coaxial resonators are offered by the companies like Integrated Microwave Corporation, and these resonators are intended for a range of application including oscillators, band pass, band stop filters and electromagnetic interference filtering. So, it is used in the EMI filtering. They can be used in the satisfying frequency requirement ranging from 200 megahertz to the 10 gigahertz, and one can select from the 9 different sizes with the range from the 2 to 18 mm, and in addition IMC offered the resonator in the 5 different material. So these type of the material are there in the. So another type of resonator is the transmission line resonators. Transmission line resonator employs sections of the transmission line to develop resonance. So if there are the terminated, if they are terminated with the reactive loads, the waves get reflected back forth and produce the standing waves at a certain frequencies. So transmission line resonators are of two type: quarter wavelength resonator and half wavelength resonator. So in the quarter wavelength resonator, these are made of sorting one end and leaving the another end is open, making the resonator, that is the quarter of the wavelength. On half wavelength, both the ends are open, and the resonator operates as a half wavelength, which is suitable for the high frequency application. And transmission line are structures that allow the broadband transmission of the electromagnetic waves, like radio or the microwave frequency. And there is a change in the impedance from open to the short in the transmission line causes the reflection of the transmitted signal. Two such reflectors on a transmission line evoke standing wave between them and thus act as a one-dimensional resonator with the resonance frequency determined by their distance and the effective dielectric constants of the transmission line. So a common form is the resonant stub, a length transmission line terminated in either a short circuit or in the open circuit, connected in the series or the parallel with the main transmission line. So there is a planar transmission line resonator, which is commonly used for the coplanar strip line and the microstrip transmission. So such planar transmission line resonators can be very compact in the size and are widely used element in the microwave circuitry. Another type of resonator is the dielectric resonator. This dielectric resonator are structures made of the dielectric material that are enable electromagnetic energy to be trapped within the dielectric, and they are more compact as compared to the cavity resonator, and they are used in the microwave circuits because of their small size and high Q value. Quality factor is high in this type of dielectric resonator. So if we talk about the types of dielectric resonator, there are the various type of dielectric resonator. Disc shaped dielectric resonator, and these are commonly employed in the filters and the oscillators, where they offer the high frequency stability and the smaller size compared to the cavity resonator. So crystal resonator oscillates employ the piezoelectric characteristics and quartz to regulate the frequency, and the crystal may be the piezoelectric type of characteristics we can take it. They are very accurate and are used in the clocks, radio and the computer. Quartz crystal resonator, and it is having the good stability and the frequency having the high frequency. So these resonators are widely used in the timekeeping devices and the frequency control circuits. So you see on the screen, this is the circuit that we can say, that is the crystal circuit. This is a symbol of the circuit. There is a box, and then that we will use in the electronic gadget. This type of circuit we use in the electronic gadget. This is the resonator. You see, we are having a C1, L1, R1 capacitance and load as well as the resistance we have there. Another type of the resonator is the ceramic resonator. Ceramic resonator are the type of resonator widely used in the electronic application due to its cost effectiveness and the compact size. And as the name suggests, they are made of ceramics material and exhibit the piezoelectric properties also. So, allowing them to generate the vibrations at the specific frequency. One of the key advantages of ceramic resonator is their low cost compared to the other types of the resonator, and this affordability makes them an all attractive choice for applications that requires the moderate frequency accuracy without breaking the budget. So ceramic resonators are also known for their compact size and making them ideal for the space constrained electronic devices. So their small form factors allows for easy integration into the various circuit and the components without sacrificing the performance and the functionality. So it will work. Typically, it is having the range from few kilohertz to a few megahertz, and they can be used in the applications such as the timing circuits, motor control, remote controls, and the basic frequency generation. So thank you very much. We will further discuss about the resonator in the next lecture. Thank you very much.